In this module, we'll look at transactions and at how simultaneous database operations affect one another. Operations in a database often require several SQL or DML statements. For instance, we might adjust a table of financial accounts, as we'll be doing in a bit here, to show a payment by subtracting an amount from one account and adding the amount to another. That'd be two update statements. Or alternatively, we might record a grade for a student, for instance, and then also update a course average grade. That'd be an insert and an update statement. In such cases, doing only part of the SQL statement group would leave the database in an inconsistent state, with only one account altered or with the course average not reflecting the new student grade. It's important that either all of the statements run or none do. All modern database management systems let you group related SQL statements into something called a transaction, and that allows you to apply them all as a single operation on the database in one collective action. To illustrate, we're going to be using this example table account here from the attached transaction test.sql file. And the table, as you can see, has columns for ID and then for name and for an account balance, and it's initialized here with the three example accounts. And we've got that set up already in a MySQL database to play around with. You should do so as well, load it up and so you can follow along with what we're doing here. Now, what we're going to do is work in a text client like MySQL, and we're going to first start a transaction with the command start transaction. Okay, we've got a brief error because we weren't connected there. What this does is announces to the database server that we are about to do a series of statements, some of which should actually not be performed, or none of which I should say should actually be performed until we commit the transaction. In the first example, we're going to do two update commands, as shown in the file here, to transfer $100 from account 2 to account 1. Right? Thus, and a select statement following those two commands shows the expected result, a transfer of $100 into Jones there. But, interestingly, if we run a separate session, and while the first session is in the middle of the transaction, the effect doesn't show. We do a select star here in this other session, and it's not evident in that session, at least not in the default MySQL configuration, and we'll talk more on that a little bit later. It's as if the transaction down here is in its own world. The database server maintains any changes within a transaction in a temporary or uncommitted state. To make the transaction permanent, we do a commit command. Now, repeating in the other session, the result of the transaction shows in both sessions, and its changes become a permanent part of the database. And note, again, all of the statements in the transaction will occur, or none will. So, if commit makes all the statements occur, how do we make none of them occur? Well, up to the point where we commit a transaction, we can abandon and erase all changes in the transaction by giving the command rollback instead of commit. And so let's try here another transaction. I'll draw it from that same file. And as you can see, this one is going to transfer $500 from account 2 to account 1. And applying that to the database and doing a select right afterward, what we see is that it resulted in an overdrawn account. It left a negative balance for ID number 2. So what we want to do is kind of undo that, and we'll issue a rollback command. And a select after that command shows that the entire transaction has vanished, as though it had never occurred. Using rollback to say, in effect, just kidding, can be a serious lifesaver when doing dangerous hand modifications to a production database. And you should always enclose such modifications in a transaction, now that you know what they are. For instance, let's delete account 3 here. but we'll do it in a transaction. So delete from account. Oh, whoa. Okay, so we got a problem here, and the first obvious thing is that it said 3 rows affected, and what I just did, of course, was manage to forget the where clause, and I just blew the account table away, right? So it's not that dramatic, I guess, in a small toy table, but it is a truly heart-stopping experience to see 12,345 rows affected in response to a query that you intended for just 1 row in a production database. And if that query isn't in a transaction, it's already done, and at least in MySQL, irreversible. A database with stronger error recovery would offer you at least a backup to several minutes earlier, but even so, it'll be a mess given the ongoing activity in a production database. On the other hand, if you make a ghastly error in a transaction, as we just did, then all it takes is a rollback, just kidding, and all is well, as you can see in the example session here. After the rollback, all the account rows are back where they should be. So, making production database changes outside of a transaction is rather like rock climbing without a belay line. You do it only if you are absolutely infallible. If you're a normal mortal like the rest of us, always put production database modifications into a transaction and check the results before committing. Now, we'll do more on transactions in a bit, but it's a good time here to introduce an important acronym in database design, and that is ACID. Standard DBMS design identifies 4 principal characteristics expected of transactions, 4 things that any correctly designed transaction system will provide. And these are summarized in the acronym ACID for atomic, consistent, isolated, and durable. And here's a brief explanation of each of those 4 characteristics. First, atomic. Atomic simply describes the all or nothing behavior we've already discussed. All statements in a transaction, if committed, are performed as a unit, in the order they were made. Or if the transaction is rolled back, then none are performed. No transaction is ever half performed. Consistent. Transactions must leave the database in a consistent state once they're committed. For instance, if we transfer money from one account to another, then both accounts must be updated to reflect the change. And it's okay for the uncommitted data in a transaction to be temporarily inconsistent, for instance, for one account to be modified before another, as long as the final committed transaction results in consistent data. Consistency can simply be a matter of correct statements being performed, but it also refers to automatic checks made by the database as part of the transaction, including triggers, which is a database feature we haven't yet discussed. Third item, isolated. Now, isolation has to do with what happens if 2 different transactions in 2 different database sessions modify the same data simultaneously. And we're going to talk a great deal about this in the next lecture segment, so we'll leave it for now. And then finally, durable. Durable is simply the idea that once committed, the effect of a transaction becomes a permanent part of the database, and it's not transient or losable, even, for instance, if the database server suddenly loses power or shuts down. And this property is ensured by the underlying implementation of the DBMS, for instance, writing committed changes through to disk instead of holding them cached in volatile memory. And then a few more details are in order before we wrap up this intro. First of all, if you don't say start transaction, then every SQL statement is its own transaction. One statement transaction automatically committed. There's no surprise there. It's sort of what you'd expect. But you can turn off this auto commit behavior by setting the MySQL session variable auto commit to 0. Now, if you turn off auto commit, then a start transaction statement is assumed at the beginning of the session, and all statements you perform go into an uncommitted transaction. So we would, for instance, already be in a transaction at this point, and if I started doing